any point on this latitude, the speed is the same thing, unless if the point leaves this latitude to another latitude. So however the question comes, they are asking for the same thing. Please note it. Okay, now they say speed. Speed is calculated from the formula distance divided by time. Distance divided by time. Now the value we are going to substitute for distance in the numerator here is the length of the whole circumference of this circle of latitude 50 degrees north, because that is where point P or any of the points the question might ask like this lies. So whatever the complete circle, the distance around the circle where that point the question is asking for is the distance, then the time will be whatever the question gave you that it takes to make one revolution, one complete turn. And in this case they said one complete revolution is made in 24 hours. So we're going to calculate the length of this entire circle, and the formula for finding the distance around the circle is 2 pi r. In this case it's going to be small r because it is a circle of latitude. Now 2 pi r is going to give us 2 all over 1 times pi is 22 all over 7 times r. Our r, remember, we calculated it to be big R cosine 50. So the only thing we need to do now is cosine 50 times this value, which is the value of big R. So let's do it. Cosine 50, the line of latitude where the point that you are finding its rotation is. Now times R, 6,400 is giving us so we are having 2 times 22 times, I have multiplied R and cosine 50 to get 411.384, then all over 7. Remember what we are finding here is the distance, so let's multiply out. 2 times 22 is already 44, then times 4113.84 is giving me this value divided by 7. So what we have there now is 25,858.423 in 3 decimal places, kilometers. So this is the distance round the circle of that latitude 50 degrees. Now the speed, which is distance over time, will now be this distance 25,858.423 divided by what it takes for one revolution to be made in hours, 24. So whatever you get after this arithmetic is the speed. It's giving us 1077.4 4343 in 4 decimal places. The unit is going to be kilometers per hour because they are talking of speed, distance in kilometers, time in hours. So this has brought us to the end of question number 5. This is question number 6, and it's going to be the last question we take in the areas of what you need to know about the topic longitude and latitude. The question says that the plane leaves an airport, maybe Murtala Mohammed Airport, or maybe that airport's in your father's farm. The airport name is X. I said it. You can know that your father's airport, your father's farm, rather, is called X. The position of that X is 20.6 degrees east, 36.8 degrees north, and flew due south. Due south has a meaning I'm going to explain to you. That means it flew on a particular longitude from that north side to the southern side. Along the same longitude, okay? You can see it for 8 hours at the rate of 1,000 kilometers per hour. I know that the aeroplanes can move at this speed, even 2,000 kilometers per hour, possible. Then to another airport, why? The one at your mother's kitchen. The point of the second airport is 20.6 degrees east, the same with X, but theta degrees south. You don't know where it went to the south. The plane continued. This plane really worked out due west. That means on a particular line of latitude from the east now to the west to another airport Z for also 8 hours at the same speed. Calculate the value of theta. I know this line of latitude where it came and stopped over before it went to Z airport from X airport. Now B, the longitude of Z, the last place the pilot came out of the plane. That is airport Z. Maybe that one in your teacher's mother's garden. Alright, assume that R is equal to 6,400 kilometers. Okay, no matter how complex it might be, we are equal to the task. First of all, let's draw our egg that represents the Earth. Draw your central pole that joins your northern side to your southern side. Put your east and west through your equator. So let's get started from here. Let's go back to the question. Airport X, 20.6 degrees east. So there is need to put a longitude on the eastern part of our globe and name it 20.6 degrees and 36.8 degrees north. There is need to create a latitude in the north. And call it 36.8 degrees north. 36.8 degrees is already in the north. So that means this is the point of the airport in your father's farm called X, airport X. This plane flew due south. That means it must be on this longitude that ran from the north to the south. Okay? Okay, from north due to the south, okay? Along the same longitude, it must be for 8 hours at the rate of 1,000 kilometers per hour. If that plane will cover 1,000 kilometers in 1 hour, in 8 hours, that means it will cover 1,000 times 8, 8,000 kilometers. Wherever this plane flew to the south, the distance it covered is 8,000 kilometers. Okay, now to another airport. Why? 20.6 degrees east, that means on the same line of longitude, but theta degrees south. So we have to create a longitude on the southern part of our globe to represent theta degrees south. So this is our airport Y. Okay? The plane continued due west. You know it's in the east now. It went to the west. Due west, that it must be on this line of latitude. If it moved due west from east, it must be on a particular line of latitude, which is theta degrees. So we have to create another line of longitude on the western side now. And we're going to call here Z. We don't know this line of longitude. Question did not tell us. For also 8 hours at same speed. That means also the distance from here to here is something from the distance from here to here. All 8,000 kilometers. We can even write it. 8,000 km. This also is 8,000 km. We are going to use these values. Okay, now the question says we should calculate the value of theta. I know that should be the first thing they will ask. This plane moved from X to Y and covered this arc. Remember, this arc is along the longitude. Every radius of any line of longitude is big R. Is the radius of the globe. No matter the value of the theta. No matter the value of that longitude. So from here, you have this radius, which is big R. From here, you also have this radius, which is also big R. Now, we know the length of this arc, which is 8,000 kilometers. So, question number A. Arc length is given by theta over 360 times 2 pi big R all over 1. The radius of any circle of longitude is the big radius, the radius of the globe. Now this theta will be calculated from, remember, the first airport X and second airport Y. They are in different positions. This one is on the north, this one is on the south. So if you want to find this angle, they subtend to the center of the globe. You add the value of the circle of latitude from where the plane left with the other value of circle of latitude to where it flew to. So our theta here now is going to be 36.8 plus theta. And this theta is what the question number A is asking for. So all over 360 times 2 pi r all over 1. Remember the arc length. They say that the plane moves for 8 hours at the rate of 1000 kilometers per hour. If every 1 hour the aeroplane will cover 1000 kilometers, that means in 8 hours it will cover 8 times 1000 kilometers, which will give you 8000 kilometers. And that was why I've written 8000 kilometers in the 2 arcs it's covered. So what you have here is equal to 8000 all over 1. By the time you do this arithmetic, you find the value of theta. So let's multiply out. On the left hand side, you have 8000 divided by 1 is equal to, what you have here is 36.8 plus theta all over 360 times 2 all over 1 times 22 all over 7, the value of theta, times, we were asked to assume that R is 6400. So instead of writing R, put 6400 all over 1. So we have 8000 all over 1 is equal to 36.8 plus theta all over 360 times, let's simplify this, 2 times 22 will give you 44 times 6400 is given out this value divided by 7. What you have here is 40,228.57 now all over 1. Now let's multiply out. What are you multiplying out? All the things you have in the numerator on the left hand side, you multiply all the things you have in the denominator on the right hand side. So we're going to have 8000 times 360 times 1. It's giving us 2880,000. It's now going to be equal to, let's multiply 36.8 and 40,228.57. Remember that this multiply this and you add it to this multiplying theta. So we're going to have 14411.38 in 2 decimal places. Then plus this value theta, have 40228.57 theta. So what I'm going to do now is we are going to take this one. Remember, I was supposed to write this here, but because of space, it cannot enter here. So I'm going to take this to subtracted from what you have on the left hand side, and we left to only this on the right hand side. So what I want to have is 2880000 minus this figure. So let's have it. It's giving us 1399588.62 is now equal to this 4228.57 theta. Now the value of theta is going to be dividing this by this. That means dividing both sides by 40,228.57. Dividing it, using it to divide both sides. When you do, it will cancel off this and leave you with only theta on the right hand side, and whatever you have by dividing this by it on the left hand side will be the value of theta. So let's do it. It's giving us 34.79 in 2 decimal places degrees is the value of theta. And that has answered question number A. And you know we have to play this question number A so that you have a space to do question number B. Question number B said we should find the longitude of a port Z. The one in your grandmother's poultry. The point Z here, remember the movement of the plane from Y to Z, it has covered this arc, which has the same distance with the one from X to Y, because it covers 1,000 kilometers every hour and it moved for 8 hours. That means it must have covered 8,000 kilometers. So let's find, from finding the length of this arc, we'll find the value or the longitude of Z. Arc length there will be given by theta all over 360 times 2 pi small r. Remember, this distance now is on a parallel of latitude. So we have big R cosine theta. Remember, this cosine theta is the angle of this latitude, not the angle these two airports subtends to the center of the circle of latitude where they are. That one will be the first theta. The second theta is the angle of this latitude, which we have calculated in question number A to be 34.79, approximately 34.8 in one decimal place. So now our arc length is going to be plus, let's say Z, which the question is asking for, all over 360 times, let's simple down this like this because of space, cosine the line of latitude that we just calculated, the east theta, to be 34.79. Remember, the arc length is 8,000 kilometers. So we are going to have that 8,000 kilometers is equal to 20.6 plus Z all over 360 times 2 times 22 over 7 is the meaning of 2 pi. So you have 44 all over 7. I'm trying to be prudent with our space. Times our big R has the value of 6,400 as given by the question. So we have 6,400 all over 1. Then times cosine of this angle. Let's find its value. This is the value we got as the answer to question number 1. So its cosine is 0.8212 all over 1. So if we solve this arithmetic, the value it will give us, or we'll be able to find the value of Z, which question number B is asking for. So let's continue. We have 8,000 is equal to 20.6 plus Z all over 360 times, let's multiply out what we have here. So we're having 33035.7 in one decimal place, which is 70286. So let's take it in one decimal place. Although it is not very advisable to begin to round up figures when you have not gotten to the last answer. But because of our space and time, we can do that. There is going to be a little bit difference in the final answer, but the difference will not be much. Okay, now all over 1. So I'm going to multiply this and this and equate it to the multiplication of what we have here and this. So we're going to have, it's giving us 2x will now be equal to 20.6 plus Z times, but it's better done like this, in bracket, then times 33,035.7. You are going to multiply 33,035.7 with Z and add it to multiplying 33,035.7 with 20.6. So let's multiply out now. It's giving us 680,535.42. Now plus Z times this will give you 33,035.7 Z. Let's write this value here so that it will not be confusing. Plus 33,035.7 Z. Yes, it entered. Now remember is equal to 288,000. Now what you do now is subtract this from both sides so as to eliminate this from the right hand side. If you want to do that on the left hand side, you're going to have 2199,464.58. It will now be equal to 33,035.7 Z. Now if you want to find the value of Z, which question number B is asking for, what you do now is you divide both sides by 33,035.7. It's giving us 66.578 in 3 decimal places, and it's going to be degrees because we are talking of the line of longitude where the plane ended its journey is now equal to Z. And that has brought us to the end of question number 6. The question we are using to draw our curtain on our discussion on longitude and latitude.